Welcome to our channel Talks on Management and Research. In today's session, we are going to cover an important topic in research called type of data analysis technique. Broadly, we can classify the data analysis technique into two categories. One is descriptive techniques and another one is inferential techniques. These both comes under the category of two different type of statistical techniques that is predominantly used. Let us discuss it one by one. Now, when it comes to the descriptive statistical technique, as the name suggests, it describes about the characteristics of the population, or in other words, whatever we are getting from the population, it used to represent it in a summarized form. Now, we can have several kinds of techniques under this. We can use a statistical technique or statistical test like mean, median, mode, charts, tables, all these things comes under this classification of descriptive techniques. Here, we don't take any particular sample of the population, but we take each and every unit of the population. Here we take a complete data set of the population and we give the entire characteristics of the population through the data that we have obtained. Let me give you an example. In the slide that you can see, I have shown you the placement statistics of SIBM B School in Pune, wherein you can see that almost 180 students have attended the placement, out of which you can see the highest placement figure is 29 lakhs per annum. After that, the median CTC is 16.25 lakhs per annum and the average CTC is 17.48 lakh per annum. So it is quite evident that what is the highest package, what is the average package, what is the median package, everything is been represented through the data that is available from the 180 students. Now this is a typical example of a descriptive statistical technique. Here you can see that I have not taken any particular sample, but I have considered the entire data of the population and I am talking about the population through the entire data that is available, right? Now this is what we call it as descriptive statistics. Now let us discuss about another technique which comes under statistic called inferential statistics. Now look at the word. Carefully denote the word. They have used something called inference. That means I am actually inferring about something through something else. Here what do? We predict the characteristics of the population through the sample that is available. That is why we have used a term called inferential statistics. So what I do is that I start predicting the population and I use something called hypothesis for this. So I take about a set of sample and I predict about the characteristics of the population. Say for example, in 2021, it is expected that the Legislative Assembly is going to election is going to happen in Tamil Nadu, and almost let's say that there are some 234 constituencies in Tamil Nadu, and I'm not sure which is the political party which is going to come. It might be DMK, ADMK, Congress or BJP. Now, if at all I wanted to know which political party is going to come to the power during 2021 MLA election, the easy way is that I need not to check with each and every 5.8 crore voters in Tamil Nadu. Instead, I can take the constituencies, start checking with 100 people each, and 100 into 234. This is the number of people that I have surveyed, and from that survey I am predicting that who is going to win this 2021 MLA election. Now this is what we call it as inferential statistics. That means instead of I conducting a survey among 5.8 crore people in Tamil Nadu, I have taken a shortcut. What I have done, I have taken 100 people each from 234 constituencies, which comes something around 23,400 samples, and from there I am predicting that who could be the possible winner in the upcoming 2021 MLA election, and I am telling this with 95% confidence with 5% margin of error. Now look at the difference in the statement, guys. When I have told you about the descriptive statistics, I did not use anything like confidence interval, margin of error. Now this normally we will not use when it comes to descriptive statistics. When it comes to inferential statistics, I am not 100% sure. I might be 90 to 95% sure, and I also have some kind of tolerance of 5 to 10%, which I call it as margin of error in statistical terms. Now this is the kind of understanding that we need to have when it comes to the inferential statistics. Now let us get deep into the inferential statistics, because most of the time we will be doing many type of analysis under the category of inferential statistics, so that we can prove or disprove our hypothesis. Now when it comes to inferential statistics, we can classify them into two broad categories. One is that parametric test, and the other one is non-parametric test. What is meant by parametric test? Make it simple. Parametric test are those tests where you have some assumption about the population. Already I have told you that inferential statistics is all about you predicting the characteristics of the population through the sample. Now this parametric test is something you have some assumption about the population from where you are drawing the sample, and this assumption is something related with normality, where you assume that the population that you are drawing is a normal data, it is a normal population. Now when you have this set of assumption, thinking that the population from where I am drawing the sample is normal and my sample data is also normal, that time I have a choice to use parametric test. Now when these assumptions are not being met, that time I will be using non-parametric test. Like this, we have classified the test into two broad categories depending upon the distribution. Right, let us discuss it one by one, so that let us get some idea on what test that we have to use for our analysis. Now when it comes to the parametric test, as I have already told you, that parametric test is usually upright for something which is normal, but when it comes to non-parametric test, it is not necessary that it should be normal, so it is a distribution free test. So the first difference is parametric test, the data is normal. When it comes to non-parametric test, the data is not normal. And the second one is that when it comes to the type of data, the type of data in parametric test is continuous. It could be either ratio or interval, and mostly it is for the dependent variable. Especially when we discuss about the techniques like ANOVA or student test, we talk only about the different dependent variable when it comes to the continuous scale. Of course, it is also applicable for independent variable also, in case if at all we are planning to use something like regression or correlation, right? Second one is that non-parametric test. In non-parametric test, the typical set of data, it is either nominal or ordinal. So it is applicable for both independent as well as for dependent variable. The third one is that when it comes to the central measures, usually we will be able to use something called mean for the parametric test, whereas when it comes to the non-parametric test, because the data that we have obtained is only in the form of either nominal or ordinal, we can use a technique like median. We cannot use techniques like mean, like in terms of parametric test. The other one is that we can draw many conclusions based on parametric test, but we cannot have so many conclusions based on non-parametric test. We can also have one more difference, like when it comes to the sample size, parametric tests require a bigger sample size. When it comes to non-parametric tests, you don't need to have that much big sample size. It might give you a good result when it comes to a small sample size also. The last one is, which is the most important in today's session, is that when it comes to the different type of test, I can use tests like independent sample t-test, paired sample t-test, so on and so forth, other type of test in parametric test, and the equivalent non-parametric test like Mann-Whitney's use test, Kruskal-Wallis test, Chisquare test. So these are all the different kinds of non-parametric tests that I can use for my analysis. So these are the main two broad classifications that we need to understand when it comes to whether we have to use this parametric test and non-parametric test. Now let us also discuss about some of the assumptions of parametric tests, so that let us give some kind of clear idea. Already I have told you about the difference between parametric test and non-parametric test. Let us discuss about the assumptions one by one, so that we will be very clear that which type of test that I need to use for my analysis technique. The number one assumption, the most important assumption is that the data that I am having about the sample or about the population, it should be in continuous form. That means either it should be interval or it should be in the form of ratio. I can't have both independent and dependent variable as categorical variable when it comes to the parametric test. This should be the first and foremost assumption for the parametric test, no matter whether you are using correlation, regression, student t-test, right? The second important assumption is that about normality. That means the sample data that I am drawing from the population should be normally distributed. Now, what is meant by normality? Make it simple. Normality is about the distribution of the data, and this distribution of the data is in such a way that most of the data is clustered around the mean, and very few data would be falling on the either sides. Say for example, if I am collecting your height and the height of the participants are ranging from 5 feet to 6 feet and the average of the height is almost 5.4, that is 5 feet 4 inches, the normality says that most of the data would be clustered around the mean. Very few people would be of 5 feet and very few people would be of 6 feet. Now, this is what we call it as normality in simple terms. Now, how do I check the normality of the data? For that, we have several tests. We have Shapiro, Wilcox test, and we have KS test. We do also have another test like skewness and kurtosis. All these tests we can use, and we can find out the data that they have collected is normal or not. But the best test that we can always recommend is that the Shapiro-Wilcox test. Now, the third assumption is the sample that I am drawing, is it independent or not? I don't think so. That is something that needs to be explained, because it says that whenever I am drawing a sample from the population, the draw what I am making, it should be independent of the another draw, right? This should be the third assumption. The fourth assumption is all about the homogeneity of variance. That means the variance of the dependent variable across the independent variable, it should be equal. That means the standard deviation of the dependent variable, which is present across 2 or 3 groups of independent variable, it should be equal. Now, this is something, it is related with ANOVA, student t-test, that we can explain it when you are explaining on the topic of ANOVA or student t-test, right? And when it comes to testing of these type of assumption, usually use a test like Leibniz test. So whenever the p-value is we have some kind of critical and a cutoff point beyond which we fulfill the assumption of this type of test, under which we reject it, right? And the fourth type of assumption is all about the fifth one is all about linearity and homoscedasticity. So now this homoscedasticity and homogeneity of variance is almost of same type. We use the word homogeneity of variance when it comes to ANOVA and student t-test, and we use the term homoscedasticity when it comes to the regression part. Linearity is all about how the variables are linearly related. If at all I say about height and weight are related with each other, the linearity is all about to what extent that height is related with the weight in terms of linear form. If you can see the slide, you can see that the dots are present. If I am able to plot the dots which is almost touching the nearby dots, that is what we call it as linearity. If this dot, if the line what I am drawing is in the straight line. Okay, now when it comes to the homoscedasticity, when it talks about the variance, is that variance is same across the line. Okay, this is what we call it as homoscedasticity. That means the dots what I have drawn is it almost having the same distance from the line. This is what we call it as homoscedasticity. So it should be like a tubular structure. Okay, now when it comes to the outliers, now outlier is another concept which comes under the sixth assumption of parametric test, which is also equally important. Say for example, if I am interested in calculating the average income of Mumbai, for me Mukesh Ambani would be the outlier. So it depends upon what kind of test that you are performing and what is the objective of your research. But usually we tend to remove the outliers. You can see that in the slide that where do you find this kind of outliers. Usually outlier, we categorize a particular variable as outlier the moment that particular variable is 3.39 standard deviation from the mean, right? So sorry, 3.29 standard deviation from the mean. So we use this number as a thumb rule so that we can categorize a particular variable as an outlier. And why it is a problem? Because if at all, if you are having an outlier, most of the time we will not get a normal data, and the skewness or kurtosis might not fall into the particular range. So sometimes we tend to take out the outlier so that we can have a normal curve, so that we can use some kind of parametric test. And the last one is, it should not have multicollinearity. What does mean by multicollinearity? The variables should be correlated with each other. That means the independent variable should be correlated with each other, but it should not have a very high correlation. So very high correlation is always dangerous, and we used when it comes to the test like even Cronbach alpha, when above 0.7 is good, but if it is going above 0.95, then there is doubtful that is my data is having a multicollinearity problem. Especially we use we give importance to this concept of multicollinearity when we are using technique like regression. So before we categorize whether I'm going to use parametric test or more non-parametric test, I need to perform all these 7 assumptions which is related with normality, homogeneity of variance, linearity, outlier and multicollinearity. And then I'll decide whether I'm going to use parametric test and non-parametric test. Now in the upcoming slides, let us discuss about the different type of parametric test and its equivalent non-parametric test that I can use for my statistical applications, right? So the next slide is fully going to be on the part of application and what type of parametric and its equivalent non-parametric test that I can use it for my analysis. Right. The first technique what I'm going to discuss today is that Pearson correlation technique. Now what is Pearson correlation technique? It measures the linearity between two continuous variables. Say for example, if I have two continuous variables like height and weight, so I can use Pearson correlation test because both the variables are in continuous form. That means it is in the ratio form. So I can use this Pearson correlation test. In this slide, I have taken the example of I wanted to study the relationship between GDP and stock market. Of course, in the short run, GDP and stock market, it may not have a positive correlation. But in the long run, if you take for decades, if you take 100-year-old data, you can always see that the stock market is the reflection of country's GDP. So I can say that stock market and the country's GDP is positively related with each other. Now when it comes to the correlation, I have a value ranging from -1 to +1. If I am getting a value of -1, it indicates that it is highly negatively correlated. +1 indicate that it is positively correlated. 0 indicate that there is no correlation between both the variables. Now I have also mentioned what should be the type of data that should be for independent variable, dependent variable, and should the data should be normal or not, and its equivalent non-parametric test that is available in front of you in the slides. So make it simple. The independent and dependent variable, it should be continuous, meaning it should be either interval or ratio. That's it. The second one is that the data should be normal. That means most of the data should be clustered in the mean. Very few data can fall on either sides. How do I check it out? Already I have told you I can use tests like Shapiro-Wilcox test. I can also check it out with skewness and kurtosis. If the value is coming near to 0, then I can come to a logical conclusion that yes, my data is approximately normal. So when these two important conditions are met, then I can also check it out other conditions. Thereby I can get the confidence that yes, I can use Pearson correlation test. If any one of these assumptions are getting violated, don't worry. We always have an equivalent non-parametric test called spearman rank correlation. I'm not going to explain fully about the spearman rank correlation, but understand that if my data is not normal, what do? I convert the data into rank, and through that rank I use this type of spearman rank correlation. Okay, let's get into the second technique. Second technique, I use something called linear regression. Now, when it comes to the linear regression, here what do? I predict the dependent variable through the available independent variable. Now, linear regression test, most of the time, I use it mainly for prediction purpose. Now, when it comes to linear regression, here also I do have two type of linear regression test. One is that simple linear regression. Another one is that multiple linear regression. Like, what is meant by simple linear regression? When I'm trying to find out the impact of one independent variable on the one dependent variable, I use a technique called simple linear regression. Say for example, I'm studying the relationship between salary and job satisfaction. Salary could be an independent variable, job satisfaction could be a dependent variable, and I'm trying to find out the strength of the impact. That time I can use a technique called simple linear regression. What is meant by multiple linear regression? Multiple linear regression is something when I'm trying to find out the strength of the impact of multiple independent variables, 2 or more than 2. That time I'll be using a technique called multiple linear regression. Okay, I have given you one example. Let's say that we wanted to study the impact of study hours and attendance and gender on examination score. Now here you can see that there are three independent variables. One, study hours, second, attendance, and third is gender and its impact on examination score. Now this I have clearly mentioned it in the form of what should be the characteristics of independent variable, dependent variable, what about the distribution and stuff like that in the slide. You can see that when it comes to the dependent variable, it should be continuous data. That means either it should be interval scale or it should be a ratio scale. And when it comes to the independent variable, it can be interval scale, ratio scale, or nominal or ordinal scale. Not a problem. We have that flexibility. We use some technique called dummy variable technique, through which we can come to a conclusion that what is the strength of the impact that independent variable is having a dependent variable, even if the independent variable is categorical. That is not at all a problem, that we can use it through this linear regression technique. And the distribution what I'm having, it should be normal. There is no compromise on it. Now, what if these assumptions are not been met? Not only these assumptions, discuss about the assumptions, 7 assumptions that I have discussed in the beginning of the session. All these 7 assumptions has to be met so that we can use these type of test. What if it is not getting met? Then the best way is that you try converting your dependent variable, in case if it is not normal, to a normal variable. How do I do that? We use few algorithms. We use some technique like z-scores, which is available in SPSS and other softwares, and through that z-score we will be able to get a normal distribution, so that I can get the first assumption of yes, it is a normality test, and I can also take out some of the outliers, and thereby I can use this linear regression test. Otherwise, one of the technique which other researcher uses is that you can also use a technique called bootstrapping. So bootstrapping is another technique which cannot be explained it in this session. That will have a separate session. We can discuss about the bootstrapping technique. Now this is what all about when it comes to the linear regression test. Okay. The third technique which we can discuss is one sample t-test. Now when it comes to the one sample t-test, it compares the means of a single sample to a predetermined value to determine if the sample mean is significantly greater than or lesser than the particular value. Now, say for example, I have some 100 men and I wanted to check whether the average height of all the 100 men is equivalent to the national average. The national average of men is 5 feet and 4.9 inch. Let's say that I have calculated the average height of this man is 5 feet and 3 inches. Now I wanted to check whether is this matching with the national average of men. Now if at all, if this is my application, the kind of test that I can use for this application is one sample t-test. I have also mentioned what should be the scale of independent variable, what should be the scale of dependent variable, okay, in this particular side. Of course, yes, the dependent variable should be continuous. That means it should be either interval or ratio, and the independent variable should be normal. Data of the dependent variable, of course, it should be normal data, and it should also fulfill all the other assumptions of parametric test. Then I can use one sample t-test. If not, if I am not able to meet the other assumptions of parametric test, I have an equivalent test called one sample Wilcoxon signed rank test. Now this alternate technique I can use. So don't get disheartened if your data is not able to fulfill the assumptions of parametric test. One way is that you can convert your data to a normal data by using z-score. Another way is that instead of you using parametric test, you can use its equivalent non-parametric test. So the choice is yours. Now let us get into another technique. Now, the other test is independent sample t-test. Now this independent sample t-test, it compares the means of two independent group to determine which mean is significantly different from the other mean. To make it very simple, it compares the means across two different groups of population, right? I have used the word two different means of two different populations. So I am not talking about the same population. It should be different population. Let me give you an example so that you can have a better understanding on this topic. Say for example, I have a new medicine for corona and I wanted to check is this medicine is effective among people. So now for that, what do? I take gender as a criteria and I give the medicine to 100 males and 100 females, and I'm checking how is the recovery rate among the men and how is the recovery rate among the women. That means I am actually checking that who is recovering faster. Is men is recovering faster or is it women is recovering faster? Now how do I check it out? I check their body temperature. Now when I am doing these type of test where I compare the mean of the body temperature across two different groups, that type of test, what I will be using is independent sample t-test. I have also given what should be the characteristics of independent variable, dependent variable in the slide. You can refer it, and I have given it in the way that you can feed this data in SPSS. That means I have mentioned it as one group. Under one group you have two groups of different population like this. Okay. Now I have also mentioned the equivalent non-parametric test, Mann-Whitney's U-test. Okay, fine. Let us discuss about the paired sample t-test, the other technique. Now here in paired sample t-test, we compare the means of the same population. Look at the difference between independent sample t-test and paired sample t-test. In independent sample t-test, I am comparing the means across two different population. In paired sample t-test, I am comparing the means across two samples of the same population. Now let me explain it. Say for example, here also I am taking this corona as an example. I wanted to have, I am checking the new medicine of corona across patient before and after the treatment. Now most of the time I use this paired sample t-test in terms of conditions or in terms of situation. That means the population will be same. Say for example, before this session, what was your knowledge on data analysis? What is going to be your knowledge on data analysis? If at all I wanted to use this assessment, and the type of test what I'll be using is paired sample t-test. In this case, I'm giving the medicine, I'm giving the treatment, I'm checking what was their body temperature before the treatment and what is their body temperature after the treatment across the same patient. Okay, not with different people, unlike independent sample t-test. Now when I'm using this technique is what I call it as paired sample t-test, and I have also mentioned the characteristics of the scale that independent variable will need to have and dependent variable need to have, and I have also mentioned the equivalent non-parametric test, which we will be using a technique called paired sample Wilcoxon test. Now let us discuss about the one-way ANOVA. What do you mean by this one-way ANOVA? Here also, here I compare the means of not just only two population but two or more population. Now, so this ANOVA and t-test, both these tests, I use it for comparing the means. When I am comparing the means across two population, I will be using t-test. In ANOVA, I can compare the means across two population, that is two groups of population or two or more groups of population. But typically, I will be using one-way ANOVA to compare three or more groups of population. Why? Though I can compare two groups, the study says that student t-test is more powerful than ANOVA test when it comes to comparing two groups. So when I wanted to compare two groups, I prefer to go for student t-test, but when it comes to three or more group, I prefer to go for ANOVA. When it comes to one-way ANOVA, in this case, I am comparing the means of two or more group, but I will be having only one independent variable. Now I will be explaining it further when I talk about two-way ANOVA, so that we will compare two-way ANOVA with one-way ANOVA. I'll give you an example. Let's say, for example, that we are comparing the CAT test exam scores across the various streams of students, including commerce, engineering, and science. When I am doing this type of comparison, the kind of test what I will be using is ANOVA, because CAT score is a dependent variable and different streams or three different groups. Okay, so the perfectly I can use one-way ANOVA for this example. Equivalent non-parametric test, I can use a test like Kruskal-Wallis test when it comes to this scenario. So mean, when you are comparing across three or more groups of population, that time I will be using a test called one-way ANOVA. Though it is also capable of testing two groups, I prefer to use student t-test over one-way ANOVA. When it comes to two groups, more than two groups, I go for one-way ANOVA. Now, when it comes to two-way ANOVA, here is the difference. Now, in one-way ANOVA, I was actually having only one nominal variable and one interval variable. Under one nominal variable, I had two groups, but when it comes to two-way ANOVA, here I am having two nominal variable with two groups each and one interval variable and normal. Now, in this case, I will be using two-way ANOVA. That means if the application is same, but instead of I having one nominal variable for independent, in case if I have two nominal variable with of course different subgroups, that time I will be using two-way ANOVA. But what is the application of two-way ANOVA? When will I use two-way ANOVA? Basically, I am using two-way ANOVA just to determine the effect of both the two nominal variables on the dependent variable. Or in other words, when I wanted to find out the interaction effect of independent variable on the dependent variable, only that case I will be using this two-way ANOVA technique. Let us say that I wanted to study the interaction effect of gender and educational level with interest to politics. Let's say that I'm collecting whether a person is interested in politics in the rating of 0 to 100. Okay, that is, it may be either in interval scale or it is in ratio scale, and I check it out whether somebody is male or female. And I'm also asking one more question: what is his or her qualification, 10th, 12th, UG and PG, whatever it is. Now I am actually finding out the combined effect, the interaction effect of gender on politics, and how this relationship is being affected by a third variable called this one, whether it is undergraduate or postgraduate, or it could be vice versa. Here I wanted to find out how the education level is affecting the interest in politics, and how it has been influenced, the strength of the impact of education level on interest in Indian politics is affected by the gender. So now this is what we call it as interaction effect. This we have explained it further in the previous videos, which you can always refer. So if this is your situation, you can use something called two-way ANOVA, provided it fulfills the assumptions of parametric test. If it is not fulfilling any of the assumptions of parametric test that we have already discussed, then not to worry about it. We have an equivalent test called either Kruskal-Wallis test in case if you are using independent group. Otherwise, you can use Friedman test if in case you are using a dependent test, dependent groups. Right. The last one is about the chi-square test. Nothing to complicate it because it is not a parametric test. So naturally there is no assumptions of normality. You need not to worry about the fulfilling the other assumptions of parametric test like I have discussed. But this is also a very popular technique which researchers uses because here both the independent and dependent variable, both the scales are nominal. Okay, they are not any continuous scale. Let's say that you wanted to study the relationship between gender and smoking, and you think that the smoking is more among men than women. So now how do you do that? You ask two questions, please indicate your gender, and you ask second question, whether you smoke or not. So now what do? You perform a simple test called chi-square test, which has a cross tabulation, and you find it out whether this smoking and gender is it interrelated with each other. And the kind of test what you will be using in this case would be chi-square test. Okay, and there is not mandatory that you need to have a kind of normal distribution curve for this because it is both of them are nominal data, right? So now what I'm trying to say is this one. Now if you can see this slide, I have clearly mentioned what type of data and what type of technique that I can use it very clearly. You can take a screenshot of it, I don't mind, so that it becomes a quick reference for you to find it out what type of test that I can use for what type of application, right? So let me conclude this session, a very long session, by a small note. Now what I'm trying to say is that refer to the previous two videos and kindly recollect the video that we have discussed it today. When it comes to the right data analysis technique, it is being affected by four important things. First, what is the kind of variable that I have identified? Is it an independent variable, dependent variable? Is it a mediating variable, moderating variable? That we have to check it out. Number one. Number two is that what is the type of measurement scale I have? Is it a nominal, ordinal, ratio, or interval? No, that is one side. And third one is that is my data fulfilling the assumptions of parametric test? Those 6 or 7 assumptions that I have already mentioned, you can refer it out. And fourth one is that what is the application? What is the situation? So based on these four things, I'll come to a conclusion that what type of test that I can use for which application. Hope you have found this technique and this session useful. Thank you very much.